Okay, so section 5.2 is interesting because I gave you a whole bunch of theorems and a whole bunch of stuff to write down. You're not really going to use in this section. You're going to need it for further sections, but not really for this one. For this one, there are a couple of things you do need to know, though. So, for example, when a segment contains another segment, we use the word contains. When that happens, that means that we can then ascribe an inequality to that. But it has to contain it because we have to have that kind of fact-based information. So what I mean by contain is AC is there, but AB lies inside of AC. It has to be inside of it in order to be contained by it. It's kind of like it holds on to it, it cradles it, it comforts it, it makes it feel good. Okay, maybe not all of that, but it does contain it. So since AC contains AB, we know AC must actually be bigger. That's where we get this information from. Notice when we say this information, we're not just saying that one is bigger than the other. We're actually saying it with the distance. The distance of AC has to be bigger than the distance of AB. That's what we're talking about. Size, not segments. Talking about distance, the actual numbers themselves. That's where we get the greater than, less than from. It has to be part of the number, which will become important that you make sure that you're talking about numbers whenever we're talking about the proofs for these things. So when we talk about angles, when an angle contains another angle, like here, such as AOC, this big one contains this little one here, AOB. When that happens, that means that we can say that the big angle is greater than the little angle. But make sure when you're talking about it, you're talking about the measures of those angles. You're not talking about just the sheer angle themselves. We can see that that's true about the angles, obviously, but the proof part is in the numbers. The number is bigger than the other number. So you got to think about it in terms of the numbers. So that's about all the information that was really relevant to what's going on in there. Can't promise I won't pull out the other stuff. Can't promise you won't see the inequalities come out at some point in time. You do need to make sure you write them down. You need to make sure everything that got highlighted gets written down. But, comma, you probably don't need to know it in order to do the homework. Just saying. So, that being said, it's time for classwork. What? Yes, the classwork you do is going to be done in the video today. We're going to do the classwork in the video, and then when you're done with this video and you've gotten all your classwork correct, because you'll check it with the video, then you are able to go ahead and do your homework, or you can wait until later to do your homework. Doesn't matter to me. So, this is the classwork. All 6 of these problems, I'll give you some time. Okay, I won't really give you some time. This is what I'm going to do instead of giving you time. I'm going to tell you need to pause the tape, and then you can find out whether or not you got them right afterwards. Is it color? No, maybe not. Maybe. We'll do green. Okay, go ahead. Pause it. Stop. I know you're writing it down. Pause it to write it down. I don't care if it does a little glitchy thing. Pause. Okay, so measure of angle 3, and then, oh, directions would have been good, wouldn't it? Oh, sorry about that. All you had to do was tell me if it was going to be a less than symbol, a greater than symbol, or equal to symbol. No wonder you didn't pause. It took you so long. You're like, what am I supposed to do with it? Well, now you know. Okay, now you should pause and do them. It shouldn't take you long. Okay, so the measure of angle 3 and the measure of angle 1, are they less than, equal to, or greater than? Well, they are vertical angles, so that's why they are equal to. Notice every time I tell you what it is, I'll give you a reason why. I'm not saying you should give the reason, but I wanted you to know the reason in case you didn't know the reason, because the reasons are important for proofs. Okay, B, measure of angle 3 and the measure of angle 5. This is angle 3, that is angle 5. Technically, alternate interior angles, but since they are not on parallel lines, doesn't matter a bit. So, alternate interior angles, but we need to know about less than, greater than, or equal to. I don't remember if you've had it or not, but I know you have had this one that says that, oh, it might have been in this one. I think it was, and I didn't write it down. This was going to be my explanation, so great. I'm glad you're here for this. All right, so when you have a triangle like we have here, any of these exterior angles that are extended out, like let's look at angle number 6 here. Angle 6 has to be bigger than this angle and this angle. In fact, even though you have not had this yet, I am telling you that it is true that angle 6 is equal to this angle plus that angle. So that means angle 6 would be bigger than either of those two remote angles. That's what they call it because it's not the linear pair angle. It's not the one at that vertex. So therefore, they're called remote angles. So when we're talking about angle 3 and angle 5, angle 3's vertex angle inside the triangle is angle 4. So the remote angles are 10 and 5, which means 10 and 5 must add up to equal 3. And since 10 and 5 add up to equal 3, got speaking going on. Since 10 and 5 add up to equal 3, that means that 3 must be bigger than 5. 11 and 4. 11 is an outside angle. 4 is an inside angle, remotely, not beside it. So that means that 4 and 5 must add up to equal 11, which means that 11 must be bigger. 5 and 7, greater than, less than, or equal to? Equal to 10 and 6. Once again, 6 is right here. It's the outside angle of this vertex angle, which makes those two the remote. So 4 and 10 must add up to equal 6. So 6 has to be bigger. And then for 8, this is 8. And they want to know about the measure of angle 4 and the measure of angle 10. Well, I've said it like 100 times now that the inside remote angles add up to the outside one. So they must be equal. But you didn't think you were going to use equal that much in a whole inequality thing, but it's all right. Okay, so that was the classwork, which leads us to the homework for this section. On page, I wrote it down, page 182. Numbers 8, 10, 12, and 14. That's it. Go forth. Be quick. See me in a little bit. Bye.